Okay. Hello, everyone. My name is Al Khatib. I'll be presenting alongside my colleague Dima Labsat, a research titled Sustainable Material in Urban Sculptures, Use of Cardboard Pipes. So the main aspect of the research is that we noticed the biggest challenges of architecture is that there is a lot of waste, and most urban sculptures and pavilions, often as beautiful as they produce a lot of waste from conceptualizing to disassembly. So a lot of the times we can see that sustainability is disregarded in fear that it will affect the aesthetic and the general beauty of the design. So our objective is to research the feasibility of fusing like recyclable and sustainable materials such as cardboard pipes and adapting it into urban sculptures and pavilions. And we selected the case of Abu Dhabi to apply this proposal in. And our three objectives were to study the properties of cardboard pipes and then test the usage of them in humid weather, and then test the application by creating organic forms. The methodology is basically this research follows a both qualitative and quantitative method. So we collected data from literature and then we analyzed it. After that, we proposed our own alternate configurations. So we identified the issue, creating a hypothesis, and we also set our objectives for the research. After that, we looked into multiple case studies that focused on unconventional recyclable materials. Three case studies were looked into one bucket at a time, Boxall and Shigeru Ban's Superpavilion, and we analyzed the usage of the material, the structure, and the concept. Then we analyzed the data and we looked at cardboard pipes and their physical requirements and constructability. The last step was the data application, where we proposed our own design and produced iteration to create like an optimal pavilion with cardboard pipes. So the first case study is one bucket at a time. This pavilion was located in Mexico City, constructed in 2017, and the material that was used was old paint buckets. So the whole idea of the project was a comment on the societal problem the Mexico faced at that time, where a lot of people would hijack parking public spaces by placing these buckets. So later they were adapted into the design, and it's an interactive pavilion. So the interesting thing about the project is that even when they used these paint buckets, these were actually reused. They were extracted from construction sites, and then the structural system of it was concealed within these buckets through the use of ropes, and this kind of created this flexible, malleable structure. And after this project was disassembled, the ropes and the buckets were reintegrated into the city. Second case study is Boxall, and it's also a pavilion. It's a research student project, and it was constructed in 2011. And it was used. The material that was used was old beer plastic crates. And what was really interesting about the project that they used a very simple system of sleds and screws, and this made sure that the connections were concealed, and the structure itself is actually very minimal and it's very simple. It has three bases that were filled with concrete, so it could create a foundation for the design. The top part was reinforced with some braces, and later, after it was disassembled, the crates were still used and reintegrated into the city.
For our third case study, it is the Souk Pavilion, which was designed by the Japanese architect Shigeru Ban. It was located in Abu Dhabi and was built in 2013. The main material that was used was cardboard pipes. Now, the pavilion itself acted as a souk and as well as a shading device from the harsh desert weather of Abu Dhabi. And it was also able to reflect the original concept of the architect, which was to highlight the region's cultural heritage. Also, the architect not only used cardboard pipes, which is a sustainable material for his project, he also used ropes as joints in some sections of the project. And also, the architect was able to deliver a great example of a sustainable outdoors pavilion using a sensitive material to the local weather of Abu Dhabi. These photographs document the construction process of the pavilion, and as you can see, the architect used different sizes for the cardboard pipes in order to achieve the desired form and look. Moving on to the cardboard pipes, which is the material we are researching about. They have been actually used in the construction process of cylindrical concrete columns as a formwork, but actually they have also been used as a main construction element in architecture and housing structures for the past 20 years in regions where there is no high humidity. Now, for the properties of the material itself, it is 100% recyclable due to the core material, which is recycled paper. It is also inexpensive because of that. It is extremely strong and stiff, and it has been proven to be great at handling wind load.
So the last part of the research is the application process, where we created our own proposal and we named it Al Barkan Pavilion. So first thing that we tried to do was understand the physical and like the requirements of the cardboard pipes themselves. So we kind of created configurations of like different shapes to kind of see the advantages or disadvantages that each one actually curates. And later we combined all of these to resolve the disadvantages, and we created a more complex design. And we can see it from here, where we created this new complex form that merges the previous tests. So the first thing that we kind of also tried to look at is to kind of create a concept, create a design that is that captures the spirit of the UAE, UAE's nature specifically. And we can see right here, we trace some curves from sand dunes, and we could also trace another curve of like the waves of the Khalij al-Arabi. So after we traced those curves, we created this solid form, and then we segmented it into 11 rails, and each rail is actually different from the other. And then we aligned pipes with variable heights and thicknesses and widths along those rails. And we made sure that we did that to kind of amplify the curve, as well as to create some structural stability and ensure that there's no gaps in between the pipes. This is how the design vision, we wanted it to kind of look like at the end, and how we wanted it to be used.
Moving on to the fabrication detail, as my colleague mentioned, it would be made out of 11 rows of cardboard pipes. Each row would have a unique curve itself, in which when combined together, they would form up the desired form. Now, for the means of attaching the pipes together, we would be using tie bolts. According to our research, they would be the most suitable form of connection due to the way they operate. Now, we used 3 different sizes for the pipes. As you can see, we have P1 with a thickness of 10 centimeters and a length of 70, P2 a thickness of 8 centimeters and a length of 45, and P3 with a thickness of 3 centimeters and a length of 90. We did that in order to amplify the curved structure and also aid in the stability of it. Moving on to the fabrication detail diagram, as you can see, it illustrates how the different sizes of the pipes would look aligned together. We would also be including cement in our grounded pipes in order to ensure the stability of our project. And for the main materials that we will be using, they would be made out of 4 materials: cardboard pipes, of course, tie bolts, acrylic spray as a treatment for the cardboard pipes that would act as an insulator to the humid weather, and also cement. Now here we have the plans and elevations. As you can see, the elevations show the different heights that our project would have. These are just renders.
So in conclusion, we did understand that cardboard pipes are a practical addition to urban sculptures and furniture, and we understood that they're very durable and adaptable to the loads because when actually given proper treatment, and due to the shape of the cardboard pipes themselves and the variability in height, width, and thickness, it allows for many designs to be adapted. And depending on its use, the material doesn't really need that much altercation. So it will not waste money or time or even extra materials for the modifications. And at the end, we noticed that they're found in like copious amounts everywhere and they're readily available. So it's not really hard to obtain them in the quantities that you need to construct the design that you desire.
Moving on to the research limitations, we faced 4, which are the time constraints, availability of the material to test it out, lack of testing of the material itself in similar environments as the UAE, and lack of research on the topic that work requires to be fully produced. Now, for the future development, we would have liked to cover 4 points, which is to explore more complex configurations and designs with the material, explore more uses for the material aside from urban sculptures, physically apply the design and actually test them in a one-to-one scale or smaller, and finally refine the design to be more adaptable to the climate and its intended uses. And thank you.